Chapter 1.7, Solving Equations in one variable. Our target today is I can solve equations in one variable. Vocabulary. Open sentence. An open sentence is an equation or inequality with at least one variable. Solution set. Is the set of all values of the variable that make the sentence true. Identity. An equation that is satisfied by all values. Example. 3 times 2s minus 3 equals 6 times s plus 1 minus 15. If we simplify this, both sides, distributive property gives us 6s minus 9 equals 6s plus 6 minus 15. So 6x s minus 9 equals 6s minus 9. So that is an identity because it is true for any number that we put in for s. Empty set. Also known as the null set. And that is a situation where there is no solution. No number makes the open sentence true at all times. Okay. Then we have some symbols. An equal sign with a question mark over it is asking, are they equal? In other words, is it true that they're equal? A pyramid or triangle of 3 dots. So a pyramid or triangle with 3 dots is translated as therefore. And of course you guys know an equal sign with a slash through it means not equal. And a 0 with a slash through it means empty set or null set. Okay, now what we're doing today is just a quick review of solving equations from Algebra 1. So for instance, if I have 3 times 2x minus 3 equals 4x plus 7, okay? Our goal in solving equations is to get the x by itself on one side and any numbers on the other side. So first thing we do is get rid of the parentheses by distributing the 3. So we get 3 times 2x minus 3 times 3 equals 4x plus 7. Then that gives us 6x minus 9 equals 4x plus 7. Then we get all our x's on one side, because remember our goal is to get x all by itself. So first we need them all on one side. So we use the subtraction property to move the x's on the right to the left. So that gives us 2x minus 9 equals 7. Then we use the addition property to move the 9 to the other side. And then we use the division property to divide everything by 2. So we get x equals 8. So 8 is the solution to this sentence. 8 is the one value of x that will make the whole thing true. Okay. Number 2. 3x minus the quantity x minus 5, that's a 5, equals 2 times the quantity x plus 4. So again, we want to get all our x's on one side, everything else on the other side. So we want to remove the parentheses, so we use the distributive property. Here we're distributing a negative, so we get 3x minus x plus 5 equals, distribute the 2, 2x plus 8. Collect like terms here, so that's 2x plus 5 equals 2x plus 8. Step number 2, get all our x's on one side. So subtract 2x from both sides. You get 5 equals 8. Now does that make sense? Can 5 equal 8? And no, it does not make sense. So this is a case where there's no number that we can put in for x that will make this true. So we would say this is no solution. We can write it like that, or brackets with nothing inside. All right, let's try another one. Example 3. 3x minus the quantity x minus 8 equals 2 times x plus 4. Again, distribute the negative. Distribute the 2. Okay. Then collect like terms. Subtract 2x from both sides. You get 8 equals 8. Now, is it true that 8 equals 8? It is, and so that tells us that the equation that we used here is an identity, which means no matter what number we put in for x, it will always be true. So our solution is all real numbers. Okay? All right, let's try another one. How about 3 times 2x plus 5 equals negative 7 times x plus 9? Okay, again, step number 1 would be to distribute, to get rid of the parentheses, because we can't do anything inside the parentheses. So we get 6x plus 15 equals negative 7x minus 63. Move all our x's to the left side, so we're going to add 7x to both sides. That gives us 13x plus 15 equals negative 63. Move the 15 to the other side, because remember our goal is to get the x's all by themselves. And then divide everything by 13. So x is going to equal to negative 6. So negative 6 is our solution. It's the one value of x that will make it true. All right, and the last thing that we want to be able to do is we want to be able to solve an equation in all variables for a specific variable. So let's say we want to solve it for t. So here our goal is to get t all by itself on one side and everything else on the other side. So what we do is we think about what would we do if the other variables were actually numbers. Okay, so this is our only variable here. So what we want to do is first of all we want to get the ct by itself. So we're going to move this c to the other side. So we're going to subtract c from both sides. So this is going to be k minus c is equal to c times t. Well, this really says c times t, so to undo times, we do the opposite, which is division, so divide by c. And by this will cancel, so by symmetric property, we get t equals k minus c over c. These equations that are in all variables are what we call literal equations. All right, let's try one last one. Let's solve w equals az plus b all over cz plus d for z. Okay, step number one, we need to get the z out of the denominator. So what we want to do is get rid of this denominator. So we're going to multiply both sides of the equation by the denominator. So put this in parentheses, and we're going to multiply this side by cz plus d, and we're going to multiply the w by cz plus d. So that's going to give us w times cz plus d equals az plus b. Okay? Then I'm going to distribute the w. Then remember, I want to get z by itself, so first I need to get them all on the same side. So I'm going to subtract az from both sides. And I'm going to add or subtract dw from both sides. Then on the left-hand side, I'm going to factor out the z. Remember the reverse of the distributive property. And then the last step, divide by wc minus a. And that gives us z equals b minus dw over wc minus a. And that is our actual solution.